Alright. So right here we're in Chapter 3, Sensations and Perceptions. So let's get to it. Alright, so sensations, learning outcomes is divide absolute threshold, explain Weber's law, and discuss sensory adaptations. Okay, absolute threshold is the smallest intensity it takes for you to be able to see or hear or smell or taste or touch something, to be able to do all those things. The smallest, like how bright does something have to be for you to see it? How much salt in your soup does there have to be for you to taste salt? How loud does something have to be for you to hear it? When you have a 50-50 chance of detecting that or not, that is your absolute threshold. It could be different for different people. Now, if your hearing's not good, if your seeing's not good, well, then it would definitely be different for everyone. The difference threshold is how much of a difference does there have to be for you to notice that there is a difference. You know, how much more salt do you have to put into your soup to notice that it's saltier? How louder does something have to be for you to notice that it is louder? How brighter does something have to be for you to notice it is brighter? You know, if I'm got my music on, you know, how many times do I have to press that volume button for me to notice that it is indeed louder? Weber's law has an effect on the difference threshold. For example, if you have very little stimulus of something, well, it takes very little of that stimulus increase or decrease for you to notice that there is a difference. For example, you know, if I'm lifting weights and I got a 1 pound, if I add another half pound, I'll notice the difference. But if I'm doing 50 pounds and I add a half pound, well, heavy is heavy to me, and I don't see much of a difference. Okay. Another example, you know, let's say a teacher who gets paid, let's say $40,000 a year, and an administrator gets paid $80,000 a year, and they both get a $1,000 raise. Who's going to notice that $1,000 more? The person who starts off with less, or a person who has more? Well, you would say that the person who starts off with less tends to notice any smaller increases or decreases. Sensory adaptation is basically you get used to it. You ever got into a really hot shower and it's so hot at first, but after a while it's not so hot? Or you know, your spicy burrito is super spicy at first, but after a while it's not so spicy. You know, you don't notice your clothes on you all day long, but they're touching your skin the entire day. You know, it's just getting used to whatever you're experiencing for a long period of time. Vision, shedding light on our eye. Okay. Alright, so I probably should have looked up your eye. Let me see if I can find it real quick. Parts of the eye. For our sake, so which one looks the easiest? This one right here. Alright, so your right hand part that you could touch is the cornea. You know, you put your contact lenses, and it keeps everything inside, like your fluids. Your eyes filled with a crystal clear fluid. In fact, if you were to stab it, it would pop. And then the pupil is a black dot in your eye that gets bigger and smaller depending on whether or not you like something or dislike, or how bright it is or dark it is. If you like something, if you think someone's attractive, your pupils will actually get bigger. So allow more of that in. If you don't like something, they get smaller. Same thing with bright lights and darkness. And this is why police officers will shine a light in your eyeballs at night to see if your pupils are responding as they should. And then right here we have the lens that helps focuses your light waves. So with far away objects, your lens actually is almost flat. With closer lens objects, it gets narrow, and your eyes have to actually work harder to see close up objects. And the back here you have rods and cones. This is your retina. This is where transduction occurs. The process of turning one form of energy into another form of energy starts right here. You're turning light waves into electrical nerve impulse. Our brain doesn't speak in light, it speaks in electricity. And there's two types of photoreceptors that do transduction. You have rods, and rods make up most of the sides of your eyeballs, okay, all the way around. And they help you see movement. They help you see at night. They see shades of gray. There's no detail. There's general outlines though, okay. And then you have cones, and most of the cones are situated in this fovea. And cones help you see color and detail. Now, it's important to understand that color is an illusion. Color does not exist in the physical real world. Color only exists inside your brain. That's the only place it exists. Your brain and everyone else's brain. That's it. The real world is more like a black and white movie. It's our brain that applies color to the world. We impose color onto the world. Okay? And it starts right here. So certain wavelength of light come in here and hit the cones. Again, colors and details, and your cones are responsible for seeing in color and detail. Okay, it's kind of like like a camera in a lot of ways. Okay, the trichromatic theory. Remember, I just told you that color is an illusion that our brain imposes on the world. That is how we see color. Alright, and it does this by having the trichromatic theory of color vision. Basically says this way, there are three types of cones that we have. Remember, we have three cones, or we have cones that help see color and detail. Well, there's three different types. One that apply the color blue, one that applies the color red, and the other one applies the color green. Okay, now if you're missing one of those, well, you're colorblind. Okay, it's not that you're color blind per se, it's just that your brain paints the world differently in comparison to everyone else. Okay, if you're missing all three of those cones, or they're not working as they should, alright, well then you're totally colorblind. You see the world as if it's in black and white. And again, it goes into your occipital lobe, and that's where you see color. That's where you apply color. Now, I am going to prove to you that color is all in your head by doing this activity right here. So what I'd like for you guys to do is to stare at this black dot for about 1 minute, starting now.
Yeah. There's a cool way you can do that. My hero. I'm going to put it on no settings. Even though the doesn't have a how many copies? 2. Oh, yeah. Well, I did remember how to do the other one, though. Yeah. Well, I thought I had it, and then I realized I did not have it. Yeah, since there's something on the back side. Yeah, that's what I think. If you just go on like this one and this one, thank you for teaching me how to use it.
Just keep staring, staring, staring. What can you do? Just keep staring. Yeah. Alright, so there you go. So hopefully what you see is the good old US of A American flag in red, white, and blue. But this picture has nothing on it. This slide is completely blank. There is nothing on the slide. You are producing those images in red, white, and blue. There is no red and white and blue on this image. None. Zero. Zilch. Zin. So what's going on here is your brain is applying color to where color does not exist. So this is how, this is part of the reason why we know color is an illusion that our brain imposes upon the world. Okay? We're on 12, I think.
Yeah, same thing.
Okay, the point of process theory, basically we just did that where we stare at a color for a certain amount of time, and then after a while we'll actually see the opposite color of that because of overworking our receptors in our cells and so forth. But again, we applied color when there was no color. There was no color at all. Okay, but we produce the color in your brain. Alright, I'm going to put a stop to this and do the second half of this with another video. Alright, thank you.